Okay, good. All right. Well, if you did not hear it before, I think it was my program was using the wrong audio input. All right, the standard form, ax squared plus bx plus c. A, b, and c are your main terms. And then for this quadratic equation here, a is 5, b is 2, and c is negative 6. Alrighty. And I also talked a little bit about how this is negative b plus and minus the square root of b squared minus 4ac over 2a. But if you're using a calculator, there's no plus minus button, so you do have to evaluate them separately. Alrighty. Okay. Important. Always find the discriminant first. Then build your quadratic formula around it. The discriminant, again, is the part that goes b squared minus 4ac. It's the part that's underneath the square root. It does not include the square root. It's just the part underneath it. All right. So step 1, put the quadratic equation in standard form, if it isn't already. Okay, and we had that listed up here. This is your standard form. Determine what a, b, and c are. Analyze the discriminant. Simplify the square root of the discriminant, and build the rest of the quadratic formula all around it and solve. Okay, so let's go ahead and do one. This one right here, it says g of x equals 1 minus 3x squared minus 6x. G of x, we can replace that with a 0. And we just need to get this into standard form. Everything's on one side, which is good. We just need the x squared term to go first, followed by the x, followed by the constant. So for this one, a is negative 3, b is negative 6, and c is 1. Okay, cool. Start with the discriminant. That's going to be b. I don't know why I wrote that as a b. That should be a 6. Negative 6. There we go. Squared minus 4ac. Remember to go ahead and use your use those parentheses. If you don't, this negative 6, you're going to end up with a negative 36, which is not what you're supposed to have. So you'll just end up getting, well, the question wrong, and nobody really wants that. All right, so you can just pop that in the calculator exactly the way you see it. You should end up with, I believe, 48. Okay, so analyzing it, this is a positive discriminant, so we can tell it's going to have 2 real solutions. And we're going to take the square root of that. Okay, the square root of 48. It depends on what you're being asked to do in the question. I know some of the questions that you're getting in like IXL just ask for a decimal. So you can go ahead and call this like 6.93 or something like that. But for right now, I want to go ahead and just call this 4 square root 3. Okay. And then we build the rest of the quadratic formula around it. So we've got plus minus the opposite of b over 2 times a. That's going to be 6 plus minus 4 square root 3 over 2. And not looking at the radical, but looking at this number, and this number, since 2 does go into all three of them, we can just make this 3 plus minus 2 square root 3. If you are looking for it as a decimal, that does end up being approximately 6.46 and negative 0.46. Okay, if that is the way the question that you're presented wants you to answer it. Alrighty. Here's another one. Find the solutions for this one right here. Okay, we want to rearrange it, put the x squared in front, minus 4x plus 8 is 0. So a is the 1 that's invisible right here. B is negative 4. C is going to be 8. And once again, the discriminant. That's going to be the, let's see, no, not opposite. Just b squared minus 4ac. Okay, this one gives us negative 16. Okay, if you don't remember, and I didn't say it in this video here, but the way it works, if your discriminant is a positive number, that means you're going to have 2 real solutions. If it's a negative number, you're going to have 2 imaginary solutions. And then if it is 0, which is neither positive nor negative, you're going to have 1 real solution. Okay, so this is negative 16. When you take the square root of that, knowing that it's got a negative involved, we know there's going to be an I as part of the answer. And the square root of a regular 16 is just 4. So we have 4i as the square root of the discriminant. From here, we can build the quadratic formula. We'll do the opposite of b, which is positive 4. And that's going to go on top of 2 times a. In other words, we have 4 plus minus 4i over 2. Similar to the last one, the number 2 goes into all 3 of those items. So this goes away. 2 goes into 4 twice. 2 still goes into 4 twice. And you end up with 2 plus minus 2i. And there's not really a decimal or any kind of thing like that one, since it's sort of a rational imaginary number of sorts. Alrighty. And let's see, this one right here, we've got, well, it's already in standard form. So this is going to be your A, that's your B, that's your C. A is 4, B is -4, and C is 1. Okay, let's see, B squared minus 4A C. Punch that in the calculator exactly the way you see it, and you'll be good to go. This does give us 0. And the square root of 0 is still 0. Okay, if we want to start it off with plus minus 0, hey, go for it. We are going to put the opposite of b here, and then 2 times a goes down here. In other words, that's going to be 4 over 8. If you want to keep going with this plus minus 0, you can, but 4 plus 0 is still 4, 4 minus 0 is still 4, so we can just ignore it, say the answer is 4 over 8, which does reduce to 1/2, or 0.5 if you're looking for a decimal. So those are a couple of the examples of the type of answers you could end up getting. Roots, solutions, and zeros. Since we are coming back to this now after spending a lot of time graphing polynomial functions, hopefully this makes a little bit more sense why we're making a distinction here, because it will always have 2 roots and 2 zeros. Okay, whether they're imaginary or real, they're still roots, they're still zeros. A quadratic equation will always have 0. I'm sorry. No, that's right. One or 2 solutions. And the graph will have 0, 1, or 2 x-intercepts. Alrighty? And we did spend a little bit of time. We learned that the discriminant, the quadratic equation, is either going to have one or 2 solutions. Okay, I guess I should have ignored that 0 here. That was me not thinking correctly. So who can claim that there will always be 2 roots? Well, that is right here. If you remember the word multiplicity that we encountered when we were doing graphing polynomials, that basically means then that that one solution counts for both spots, kind of like the 1/2 counted for both spots. So if we were graphing it, that would be a bounce instead of a through, if you remember all of that stuff. Okay, that's basically it. Everything else that's on here is just more examples of using the quadratic formula. I can reserve those for later if you want me to pull them out for a Schoology conference that I've got scheduled for 6 o'clock this evening. Hopefully Schoology will be up and running again fine. But if there aren't any questions, I will go ahead and call it a video. All right, talk to you guys later.